Here we have another problem which is also related to Thevenin equivalent, but this question is formed a little bit differently, so that's why I took this question. First you go through the question and think about some method that you can use to solve, and you try it yourself first. Okay, now so in this question there are two parts. There's the first is this part, and there's the next question is this one. Okay, so first we are going to solve the first part. What is being asked here? Now it's given that if the voltage source V is 10 volt, then if we connect 1 ohm resistance, we get 3 ampere current, and if we add, so I'll just highlight this part, 1 ohm and get 3 ampere, and if we add 2.5 ohm, then we get 2 ampere. So we have to find the value of VTH and RTH. So as you can see in this question, we have a linear network and there are two sources. One is this voltage source, and one here in the bottom there is a current source here and here, right? Now since the voltage value is 10 volt is given, so we can assume that that is not going to change, right? So whatever linear network we have here, that will give us some voltage that will be VTH, right? Because whatever we connect at this AB terminal is not going to affect the linear network, right? So if we don't connect anything in this part in the load, so this voltage VTH is going to be constant. Yes, and obviously if we change the voltage here and the current here, then this VTH value will change. I hope this is clear, because we're not changing the network, right? So nothing is going to change at the output terminal, which is the AB terminal. Yes, now let's come to the question again. So we can assume this network is like a VTH and RTH, because RTH the resistance which is related to this whole part, just this part, right? So now let's put 10. So now we connect 1 ohm resistance, and this is VTH. Then we are getting current as 3 amps, correct? So now we can say that VTH is equal to 3 into RTH plus 1. Again, this is one condition. There's another condition given. If we connect 2.5 ohm, then we'll get, instead of 1, I'll just add 2.5 ohm, then the current is 2 ampere. So now we can get another equation which will be VTH equal to 2 into RTH plus 2.5. So there is this 1, this is 2. We are getting this from the two condition that is given. Yes. Now if we solve this, we'll get 3 into RTH plus 1 is equal to 2 into RTH plus 2.5, because we have to find the RTH of the linear network. Okay, so let's solve this. That will give 3 RTH minus 2 RTH into 5 minus 3, that will be 2, so that will be RTH is equal to 2. I hope this is clear. Now coming to the second part of the question, it's given that if we change the voltage source to 6 volt, then we connect 1 ohm resistance, then the current becomes 7/3 amps. Okay, then we have to find the VTH for V is equal to 8 volt. So since this is a linear network, we will get some linear equation using the voltage and current value. Okay, so let's form some linear equation. So we've got RTH is equal to 2 ohm. Now you see that this resistance is not going to change, right? Because that is the internal properties of the linear network. So now we will get equation for the VTH that will be a function of basically the voltage source and the current source. So we can write this as AV plus BI, that will be VTH. Okay, so to solve this we need two equations. So from the first part of the problem we can get this VTH, this was the scene, right? So here we had VTH, and if we connect 1 ohm, then we are getting 3 ampere, which is given in the problem. Yes, so from this and RTH we already got 2 ohm. So from this we can get VTH is equal to 3 into 3, that is 9 volt. We're just using V is equal to IR. Okay, this is into R, that will give us 9 volt. So from here we can make an equation which is like from here. Okay, so this is 9 equal to A into 10, because the voltage source that was in this part here, you can see this 10 volt and this current we are taking here. Okay, this is the I, and I is given 1 ampere. Yes, on the problem. So A into 10 plus B into 1, this is one equation. And the second one, only the voltage is changing, not the current. So we can get another equation. As you can see, it is given V is equal to 6 volt and current we are getting 7/3 amps. So in that case, let's take this same thing here. We're taking the voltage is 1 ohm resistance again, but the current becomes 7/3 amps. So here we will get VTH is equal to 7/3 into 3, that will be 7 volt. Yes, 7/3 is the current and R3 is the resistance, that is 2 plus 1. So this is one equation, and the next equation will be 7 is equal to A into 6 plus B into 1. Yes, so this is equation number 1, equation number 2. Now we have to find the VTH for the voltage 8 volt. Okay, so if we solve this, we'll get equation, we'll do 1 minus 2, then we'll get 2 is equal to 4A. So A will be half. Okay, and if we put this value in equation number 1, then we'll get 9 is equal to 5 plus B. So B is equal to 4. Alright, so now if we put this equation, VTH is equal to A. Here we are using A into 8. So A is half into V is changed to 8, right? And B is 4 and the current is 1. So the equation will be, the answer will be 4 plus 4, that will be 8 volt. Alright, so I hope this is clear. If you have any doubt, please write in the comment section. Alright, thank you.